Magba is still here, and in today's video we're solving a past question, JAMB 1995, and we're solving question 15. The question says a gas at a volume V0 in a container at pressure P0 is compressed to 1/5 of its volume. What will be its pressure if it maintains its original temperature T? Of course, we have some possible options A, B, C, and D. Now let's step into the solution right away. Now from the question it says a gas at a volume V0. That means V1 is equal to V0. In a container at pressure P0. So that means P1 is equal to P0. Is compressed to 1/5 of its volume. This is our V2, 1/5 of the initial volume, and the initial volume was V0. So V2 will be equal to 1/5 of the initial volume V0. Now the question says, what will be its pressure if it maintains its original temperature T? So we're finding P2. P2 is unknown. The question says, what will be its pressure if it maintains its original temperature T? That is, if temperature is kept constant. And from that question, we can see that the temperature is kept constant. So we're going to use Boyle's law. Of course, we have different gas laws. We have Boyle's law, we have Chance law, we have Gay-Lussac's law, and of course many other laws. Now, in this kind of question, we're going to apply Boyle's law, because Boyle's law states that the pressure of a fixed mass of gas is inversely proportional to its volume, provided the temperature remains constant, or provided that the temperature is kept constant. Now, Boyle's law mathematically can be stated as Boyle's law mathematically can be stated as P being inversely proportional to V. Now, if we introduce a proportionality constant K, our P will be equal to K over V. If we introduce a proportionality constant K, our P will now be equal to K over V. And this is the mathematical statement of Boyle's law. Now, that implies that PV, that is P times V, will be equal to K, will be equal to constant. P times V is equal to constant, and this law can be mathematically stated as P1 V1 being equal to P2 V2. So this is a mathematical statement of Boyle's law. P1 V1 is equal to P2 V2. Now, we already have the value. This is the formula we're going to use. We already have the value for P1. Of course, we have the value for V1. We have the value for V2. What we're looking for is P2. We're looking for P2. And how do we make P2 the subject of the formula? By dividing both sides by V2. If you divide this side by V2, and of course divide this side by V2, V2 will cancel V2, and we'll be left with P2. So our P2 will be equal to P1 V1 divided by V2. So in essence, P2 is equal to P1 V1 divided by V2. Now let's put in the values to find our P2 right away. Now our P1 from the question is equal to P0. Of course, our V1 is equal to V0, and our V2 is equal to 1/5 of V0. Of here implies multiplication. So we're going to say that 1/5 of V0, that is 1/5 times V naught. So we have done, we're through with that stage. Now V naught, we cancel V naught. So V naught, we cancel V naught. We're now left with P naught divided by 1/5. We have P naught dividing 1/5, and this implies that P2 will be equal to P2 will be equal to P naught dividing 1/5. Hence our P2 will be equal to by introducing a multiplication sign and taking the inverse of 1/5, we have P naught multiplied by 5/1. So that is our final answer. And how do we simplify this further? We're going to have 5 times P naught is equal to 5 P naught. 5 times P naught divided by 1 is still equal to 5 P naught. So our P2 is equal to 5 P naught, and that is our final answer. Now if we take a critical look at the options, we have A, which is P naught divided by 5, it's not correct. We have B, which is 4/5 multiplied by P naught, is still not correct. Of course, we have C, P naught is still not correct. And then we have D, 5 P naught, which is the correct option. So option D is the correct option. Option D is the correct option, and we're done with that. We're going to step into other calculations in our subsequent videos. If you're interested in this kind of video, don't forget to like and share. Also subscribe to my YouTube channel, MustT Online Class. Follow me on TikTok, MustT Online Class, and of course on Facebook, MustT Online Class and MustT Kumagwe. Thank you for watching, and God bless you. See you in the next video.